change. Living things change over time. There are little changes and big changes. Whoa. That's evolution.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T-minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the most advanced life form on the planet Earth. At least until something better comes along.
Do you realize that every living thing on Earth has been changing for the last 3 billion years? That's why we're all so different. Well, we are different. But as different as we all are, we all have a lot in common because we're all made of the same few basic chemicals. Now, this process, this thing that happens, is called evolution. And it's been going on for billions of years. Isn't that wild? That is kind of wild. So take a look at this. It's a picture of my parents. And I'm going to make a photocopy of it. Now watch. See, the copy looks just like the original, but not exactly like it. There are some small differences because there's some small changes that happen every time you make a copy. The same thing happens when living things make copies of themselves, like when they have children. See, the children of living things are always different from their parents, but not completely different. I mean, they're related. They have the same genes. Now, genes are made of a very complicated chemical called deoxyribonucleic acid. Deoxyribonucleic acid. Deoxyribonucleic acid. We usually just call it DNA. DNA. Now, here's a model of a gene, of a piece of the DNA molecule.
Okay.
Now, the genes of you and me, giraffes, fish, seaweed, our genes are all made of DNA. We're all made of the same basic chemicals. We're all made of DNA. Dinosaur genes are made of DNA. So you and I are the product of billions of years of tiny changes to our DNA. They happen every time living things make copies of themselves. Like every time we have children, when your grandparents had your parents, and when your parents had you. This process of change is called evolution. It's the reason we all look the way we look.
So all the organisms on the Earth, even though they seem to be different, are fundamentally the same. Their chemistry is all identical. And they're just wrapped in different kinds of wrappings. Us bacteria and us people and us plants and us protozoa, we're all the same on the inside.
Life. How it began, no one knows. But it is thought that life was created by chemical reactions in quiet pools of water.
How did life get started on Earth? Where did evolution begin? Well, near as we can figure, the ancient Earth was covered with the ocean a little over 3 billion years ago. And the ocean was a sort of primordial soup that living things got started in. Now, primordial, that's an old word that means very old. See, scientists have done a famous experiment with primordial soup where we cook it. The experiment would look something like this. Put primordial soup in a big flask, cover it with what we believe to be the ancient Earth's atmosphere, which would be ammonia. And ammonia is the same stuff you smell when you clean a window. We cook it by heat from the sun, and this would be freshwater rain, which would come out of this boiling flask right here, and lightning from primordial thunderstorms. The thunderstorms make the molecules change and rearrange themselves. And eventually, we have found that we can reproduce tiny pieces of deoxyribonucleic acid, tiny pieces of DNA. The very building blocks of life,
the blueprint for future generations,
can be made with an experiment somewhat like this one. So the primordial soup was very much like the ocean is today. Look at all these living things. The ocean's full of them. You and I are living things. The primordial soup is still cooking.
DNA is a molecule containing the genetic message, the blueprint for future generations. This genetic code is the same for all living creatures, for all life, which means that there is really only one form of life on Earth.
Excuse me, are those Frugal Boy jeans that you're wearing?
Well, actually, these jeans are custom made to fit only me. This is just one of hundreds of genes that are found on each and every one of my 46 chromosomes. Now, each gene and a chromosome...
Hey! This is DNA! These are the chromosomes I'm talking
Frugal Boy
about.
genes, for those who have evolved.
On a desolate world where evolution has gone wild,
A lone astronaut faces sure extinction unless she can learn to adapt. Trapped in a land where crustaceans rule with an iron claw, it is the human who will have to evolve to survive on Planet of the Crabs.
Progressing from simple, spineless shapes to more complex forms, animals develop a backbone and receive a first vertebrae.
If you have 4 legs and you like to gallop around, maybe you're a zebra, or a springbok, or a giraffe. Now, if you're a giraffe, why do you have such a long neck? Well, please consider the following. Now, when you watch giraffes eat, you'll see that they eat leaves up high in trees. That's what giraffes do all day. They eat leaf tree salad, leaves that other animals can't reach. Now, you might think that if you were another animal and you wanted to reach those high leaves, you just stretch your neck, stretch, sort of stretch. And then eventually, you'd be able to eat leaves up higher in trees. Well, it doesn't work that way. In order to have a slightly longer neck, you have to be born with one. Just slightly longer. Just slightly longer. So having a slightly longer neck, just slightly longer, allows you to reach leaves that are slightly higher. Slightly higher. And that gives you a slightly better chance of having enough to eat, which gives you a slightly better chance of having giraffe kids. Or gids. See it because it begins with a G. Anyway, the kids with slightly longer necks, just slightly longer, have a better chance of having kids with even longer necks. And eventually, after millions of years and many, many generations, giraffes ended up with pretty long necks. This is the process of evolution by selection. Small changes with each generation. So big changes take thousands of generations, millions of years. And that's how giraffes get to have such long necks.
Maybe these guys are onto something. Looks good.
Thank you for joining me. I'll confer the following.
Shallow waters, where they are in close contact with the bed of the sea, fins of the fish gradually disappear, and crude legs take their place. Near the shores, fish slowly lose the use of gills and develop lungs.
My name is Lisa White, and I'm a paleontologist at San Francisco State University. I study fossils, particularly shells of organisms that lived millions of years ago. These organisms tell us lots of things about evolution, how creatures have lived in the past, and how they've descended through time. This beautiful creature is a pearly nautilus. It lives in the open oceans. It's had a long history of evolution. If we look at this big guy here, I can hardly lift it, you can see that in the past, these kinds of organisms have been much, much larger. This is an ammonite, and it ruled the ocean 70 million years ago. The coolest fossils, though, are the microfossils, the ones that are so tiny you need a microscope to see, and they're in rocks as ordinary as this one. These are the fossils from the rock, and this is what they look like when we examine them under the microscope. You can see that they're different shapes and sizes. Some are in circles, and some are long, and they're all different kinds of shells. And when we examine them through the geological layers, we can interpret past climate and how these plants have evolved. So these fossil plants tell us so many important things about the ocean, and so do the fossil animals. Paleontology is the study of life through time. I get to try and understand the principles of evolution, how creatures have changed through time, and maybe even how creatures may continue to change in the future.
Legs grow sturdier, and animals become land-water creatures called amphibians. Other creatures, emerging from the waters, make the land their home, become reptiles, and grow scales, such as these.
Living things evolve, living things change, but not that fast. Now here's a dam that humans put here, and over here is a fish ladder. And here's the idea. Fish can swim from step to step and get up the ladder and get up past the dam. Do you see what I'm saying? But do you see one fish? One big salmon over there? I mean, salmon are big. You see one? Not one. I mean, salmon are like this. You think I'm telling you fish don't know they're big fish. But they're over there, you'd notice them. Some people say the sea lions are eating them. Well, the sea lions might eat a few fish. Maybe they eat a lot of fish. But they don't eat this many fish. I mean, it's a lot of fish that aren't getting past the dam. They aren't getting up to this fish ladder because humans have changed their environment. Humans have let silt come downstream, chemicals get in the water. They dam the stream up altogether so the salmon can't swim past. And you know what else? It's not one person. Millions and millions of humans slowly degrading the streams, made the environment not so good. See, no salmon. You know what I'm saying? Because humans have changed the environment. Now, a fish could adapt. It could evolve. But it would take millions and millions of years. It's not going to happen in 100 years. It's not going to happen in a weekend. It takes a long, long time. Humans have changed the environment faster than most living things can keep up.
The more places something can live, the better chance it has to survive. Like this moss. Over the past 3 billion years, moss has evolved so it can live almost anywhere. Check it out. Put some moss in a blender. Add some milk.
Yum.
Now, blend it up. But whatever you do, don't drink it. Don't drink it. Whatever you do, don't drink it. I said, don't drink it!
This is your announcer reminding you, don't drink it.
Take your moss milk outside. Pour it in some cracks on the sidewalk, or on some rocks, or anywhere. Wait a few days and take a look. No matter where you put the moss milk, it grows. Wow. Moss. It's soft, it's simple, and it's evolved to live everywhere.
Living things have been changing for many years. Fossils, like this one, show how life has changed on Earth. This is a fossil of a very old animal called an ammonite. It had a hard shell and lived in the ocean 200 million years ago. Its relative today is the squid. Now that's what I call a distant relative.
The ages roll on and reptiles grow to enormous size. As the giant reptiles become extinct, smaller ones appear. Other species grow feathers and wings and become birds. Some adapt themselves to water, as well as land and the air. And a great variety of flying creatures develop.
Some scientists believe that the descendants of dinosaurs are still around. Yeah, and they're birds. See, dinosaurs had scaly skin like reptiles. And the scales in a reptile's skin is made of almost exactly the same stuff as the feathers in bird skin. Also, dinosaurs laid eggs, and so do birds today. Now here's Archaeopteryx, an animal that lived about 200 million years ago. It had feathers on the outside like a bird, but its skeleton on the inside was like a dinosaur. So, was the Archaeopteryx the end of the line for dinosaurs, or the beginning of birds? See, the answer for scientists is still up in the air. See, that's a joke about being a bird.
From another branch of the early land water creatures are developed a warm-blooded, hair-covered group called mammals, who, unlike egg-laying creatures, bear their young and feed them by nursing.
Living things on Earth have been changing for billions of years. Now take a look at this. These are the fossil bones of a giant ground sloth, a type of animal that used to live on Earth about 12,000 years ago during the last ice age, but it's completely disappeared. There are no giant ground sloths anywhere. But here are the bones. Something happened in the environment. Something changed so that ground sloths couldn't find a way to make a living anymore. And they're gone. This is a saber-toothed cat. Look at those long, sharp teeth. They look pretty mean, like they could do a lot of damage. But even so, cats like this aren't around anymore. This skeleton dates from about 30,000 years ago. And since then, something in the environment has changed so that cats like this can't live, and they're gone. That's evolution.
Nucleic acids are genes contained in chromosomes, the basic unit of life. These combinations of molecules distinguish living things from non-living systems.
Hey baby, let's evolve together.
Solid in a Rock. Just $19.95 for 8-track only. Order today.
The size and shape of living things in nature changes naturally by evolution, what we call natural selection. Natural selection. But the size and shape of living things can be changed by humans. Like this dog, this Commodore, was bred by people for guarding sheep. Other dogs, like poodles, bred to swim well and retrieve things out of the water. Now, a dog like a Rottweiler was bred to be strong. Other dogs, like this Chihuahua, are actually very good watchdogs. Even though they're small, they're very alert. Now, all these different types of dogs, all these different sizes and shapes were created by humans, choosing which dog bred with which dog. It's all part of what we call artificial selection. It's just like evolution, but humans do it. The same thing works with plants, like broccoli and cauliflower can be mixed together to make broccoflower. And tomatoes can be this big, or this big, and yellow. See, it's artificial selection in plants.
Hello, I'm Charles Darwin. I developed the theory that through billions of years, all species of living things evolved from a common ancestor. It's just a theory, of course. but I think I'm right.
Oh, hi. I was just looking at these finches, these birds. These are the same types of birds that Darwin was looking at when he visited the Galapagos Islands. He noticed that different types of finches were all very much the same, but they had different coloring in their feathers and different shaped beaks. Darwin realized that these different types of finches, he counted 13 in all, must have all started out as one type of finch. As they each found special things to eat and special ways to live, they changed, evolved over thousands and thousands of generations.
With the discarding of the once popular Darwin theory that man descended from the ape, we are now presented with a new one, which suggests that man and the ape came from the same stem of the evolutionary tree, but that man branched off and ascended, while the apes degenerated.
Oh, hi. I was just swinging on a rope there. You know, the animals that we descended from, that lived millions of years ago, used to be able to swing through trees on their tails. Their tails allowed them to hold on to branches, and they could use their tails to keep their balance. If we had tails now, though, kind of be in the way, because we walk standing up. We walk standing up. But if you look at a human skeleton, like Terry here, you can see that we still have a tailbone called our coccyx, right there. So that's left over from the animals that we descended from, that had big, long tails. See? So that's sort of the end of our tail, the tail of this part of the show. Tailbones.
Much faster.
You're looking at my face, you think I look strange, but in a million years you bet there'll be a change. In a million more, who knows how we'll look. Life changes over time, like pages turning in a book. Survival is a problem, one that must be solved. If you don't adapt, then you must know you won't evolve. A bat's got wings, a duck's got a beak, a fish has gills, a man can't speak. All related to each other, we got chemical proof. The stuff found in your toenails is like a horse's hoof. Survival is a problem, one that must be solved. If you don't adapt, then you must know you won't evolve.
And from the mystic past comes the voice of nature, calling through the ages. Change. Change. Everlasting change.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some facial enhancements to investigate. See ya!
Produced in association with the National Science Foundation.
The same thing works with plants. For example, like broccoli and cauliflower. Broccoli and cauliflower can be mixed together to make broccaflower. And tomatoes can be this big, or they could be this big and yellow. Yeah, so these would be artificial selectively. No, wait, no, it would be plants made with artificial select. This big, or this big and yellow.